Right now, you're blind to 99.9999% of the universe. And I'm going to show you why. Here's something that'll blow your mind. You've never actually seen the universe. None of us have. We think we understand how big space is because we've seen pictures, read the numbers, heard the comparisons, but our brains literally cannot process what's really out there. And tonight, I'm going to fix that. By the end of this video, you're going to see the cosmos in a way you never have before. And trust me, you'll never look at the night sky the same way again. Before we start this journey, if you're into having your mind completely rewired about reality, hit that like button. It genuinely helps this channel reach more people who are ready to have their perspective shattered. Let's start with something you can see. Hold your hand up right now. Look at your thumb. The width of your thumbnail is about 1 centimeter. Keep that measurement in your head because we're going to use it to unlock the entire universe. Now, imagine I told you that every single star you've ever seen in the night sky, every constellation, every shooting star, every point of light you've gazed at in your entire life, all of it fits inside a space that's proportionately smaller than your thumbnail compared to your house. You'd think I was lying, but I'm not. Here's what we're going to do. We're going to take the entire observable universe and scale it down until you can actually see it. And then we're going to zoom back in, stopping at different points to reveal things that will fundamentally change how you see reality. The universe isn't just big. It's big in a way that makes big a meaningless word. And the only way to truly understand that is to see it at a scale your brain can actually handle. So let's do something no one's done before. Let's make the universe visible. We're going to start by shrinking the entire observable universe down to the size of Earth. Yes, the entire universe, all 93 billion light years of it, compressed into a sphere the size of our planet. At this scale, where's the Milky Way? Our home, with its 400 billion stars. It's smaller than a grain of sand. Actually, it's about the size of a red blood cell. You couldn't see it without a microscope. But here's where it gets weird. At this scale, where's our solar system? It doesn't exist. It's gone. Too small to measure. If the universe is Earth size, our entire solar system, everything from the sun to beyond Pluto, is smaller than an atom. Smaller than a proton inside that atom, actually. And Earth? Earth at this scale is so small that there's literally no physical object we can compare it to. It's smaller than the smallest subatomic particles we've ever detected. It's essentially a mathematical point. It has ceased to exist in any meaningful physical way. Think about that. The planet you're standing on right now, with all its mountains and oceans, all its cities and forests, every human who's ever lived, all of it compressed to something smaller than quantum physics can measure. And this is just our first scale. Let's zoom in. Let's blow up our red blood cell-sized Milky Way to something we can actually see. Let's make it the size of the United States. Coast to coast, 3,000 miles of galaxy. Now where's our solar system? It's about the size of a quarter, maybe smaller. 25 cents worth of space containing 8 planets, hundreds of moons, and billions of asteroids. And Earth? Even at this scale, Earth is invisible. It's smaller than a speck of dust on that quarter. You'd need a powerful microscope to find it. But here's what's really disturbing. That quarter-sized solar system isn't floating in a crowded space. The nearest other solar system, the nearest other quarter, is about 40 miles away. That's how much emptiness exists between stars. Space isn't full of stuff. Space is nothing, with occasional bits of something scattered impossibly far apart. This is what people don't get about the universe. It's not that it's big, it's that it's mostly empty, overwhelmingly, crushingly, almost entirely empty.
If you could remove all the empty space from every atom in your body, if you compressed yourself down to just the actual matter with no gaps, you'd be smaller than a grain of sand, and you'd weigh exactly the same. The universe is playing a trick on us. It looks solid. Earth feels solid under your feet. You feel solid. But almost all of what you think is there is actually empty space. You're mostly nothing. Earth is mostly nothing. Even the sun, that massive ball of fusion, is 99.9% empty space. And when we zoom out to cosmic scales, the emptiness becomes so extreme, it's almost philosophical. Let me show you what I mean. Everyone knows light is fast. Light can circle Earth 7.5 times in 1 second. That's 186,000 miles per second. Nothing in the universe is faster. So here's a question. How long does it take light from the sun to reach Earth? 8 minutes and 20 seconds. The sun is so far away that if it exploded right now, you wouldn't know for over 8 minutes. You'd keep living completely unaware for 8 minutes after the sun ceased to exist. But the sun is close. That's our backyard. The nearest star beyond our sun? Proxima Centauri. Light takes 4.24 years to get here from there. Let's make that tangible. Imagine you could travel at the speed of light. You're moving at 186,000 miles per second. You could reach the moon in 1.3 seconds. You could lap Earth 7 times in 1 second. At that speed, you'd reach Proxima Centauri in 4.24 years. But here's the thing. You can't travel at light speed. It's physically impossible. The fastest spacecraft we've ever built, Voyager 1, would take 73,000 years to reach Proxima Centauri. And that's the closest star. The Milky Way galaxy is 100,000 light years across. If you traveled at light speed, it would take you 100,000 years just to cross our own galaxy. But let's talk about what that really means. Remember, we can't actually travel at light speed. So let's use Voyager 1 speed again. That's the fastest thing humans have ever launched. At Voyager's speed, crossing the Milky Way would take about 1.7 billion years. Earth has only existed for 4.5 billion years. Crossing our galaxy at our best speed would take more than a third of Earth's entire existence. And the Milky Way is just one galaxy. There are 2 trillion galaxies in the observable universe. Most are millions or billions of light years away from us. The Andromeda Galaxy, our nearest large galactic neighbor, is 2.5 million light years away. At Voyager 1 speed, reaching Andromeda would take 44 billion years. The universe itself is only 13.8 billion years old. Do you see the problem? We're trapped. Not just on Earth, not just in our solar system. We're trapped in our local area of space by distances so vast, they might as well be infinite.
This is what keeps me up at night. Even if aliens exist, even if intelligent civilizations are scattered throughout the galaxy, we might never meet them. Not because they're not out there, but because the distances are too great. Let's say there's a civilization 1,000 light years away. They're watching Earth right now through a super powerful telescope. What are they seeing? They're seeing Earth as it was 1,000 years ago. They're watching medieval Europe, knights and castles. They have no idea we've discovered electricity, built cities, gone to space. And if they decided to send us a message right now, traveling at the speed of light, that message would arrive on Earth in the year 3025. None of us would be alive to receive it. If we sent a reply, they'd get it in the year 5025. 2,000 years just to say hello and hear hello back. This is the universe we live in. The distances are so vast that even communication might be impossible, let alone actual contact. We are alone. Maybe not biologically. Maybe life is common out there. But practically, functionally, we are isolated on our tiny planet by distances that dwarf imagination. And here's the truly disturbing part. It gets worse. The universe is expanding, not just drifting apart slowly, accelerating, getting faster. Right now, distant galaxies are moving away from us faster than the speed of light. Not because they're traveling that fast through space, but because space itself is expanding between us and them. There are galaxies we can see today that we will never be able to reach, even if we somehow invented light-speed travel tomorrow. They're already too far away. The space between us and them is expanding faster than we could ever cross it. In the far future, billions of years from now, the expansion will have carried distant galaxies so far away that their light will never reach Earth. Future civilizations looking up at the night sky will see far fewer galaxies than we do. Eventually, they'll only see their local cluster. The rest of the universe will have disappeared beyond an unreachable horizon. The universe is actively erasing itself from view. We're living in a rare moment in cosmic history when we can actually see the broader universe. In deep time, that view will be gone. Remember how I said space is mostly empty? Let me show you just how empty. If you map all the galaxies in the observable universe, they form a structure called the cosmic web. Galaxies cluster along thin filaments, like a three-dimensional spiderweb spanning billions of light years. Between those filaments are voids, enormous regions of nearly empty space. The largest known void is about 2 billion light-years across. Almost no galaxies, almost no stars, almost nothing. If you were somehow placed in the center of that void and looked out in every direction, the nearest significant galaxy cluster would be 1 billion light-years away. The night sky would be almost completely black, maybe a few dim, distant smudges of light. That's it. Our Milky Way sits on a filament of the cosmic web. We're in a relatively crowded neighborhood by cosmic standards. But even here, even in our crowded region, space is almost entirely empty. So let's come back to Earth, this planet that seems so large to us, this planet we fight wars over, draw borders across, argue about resources on. Earth is a speck on a speck, orbiting a speck, in a speck of a galaxy, floating in an ocean of nothing. Every human who's ever lived, every civilization that's ever risen and fallen, every war ever fought, every discovery ever made, all of it happened on a world so small that from even modest distances, it literally disappears. But here's the thing. That doesn't make us insignificant. We're the only place in the universe we know has life. We might not be alone, but we're the only confirmed example. And not just life, conscious, intelligent life that can look up at the cosmos and understand it. That's remarkable. Maybe it happens everywhere. Maybe every galaxy is full of civilizations, or maybe it's incredibly rare. Maybe we're the only ones in billions of light years. We don't know. But until we find others, we have to treat Earth like it's precious, because it might be all there is. The universe is vast, beyond comprehension. The distances are crushing. The emptiness is overwhelming, and Earth is almost invisibly small. But Earth is also home, and that matters more than size ever could. The next time you look up at the stars, remember what you learned tonight. You're not just looking at lights in the sky. You're looking across impossible distances at ancient light from objects so far away they might not even exist anymore. And you're doing it from a tiny planet that defies the cosmic odds just by being alive. If this video changed how you see the universe, hit that like button and subscribe. There's so much more to explore together. You're standing on a speck, but it's the most important speck we know. Thanks for watching. And remember, you're not small. You're infinite consciousness, experiencing itself in finite form. See you in the next one.